This particular research paper or this particular effort is associated with these two folks, the names that you see here, Rohit and Nishit, but due to some unavoidable circumstances, we are not able to make it. So we are trying to fill in for them. We'll try our best, right? And then we'll try and keep it short as well. So blockchain, right, or insider threats, these are like common topics. Like anybody in security would probably know what insider threat is. So first of all, right, I was thinking about this. Any presenter who talks about blockchain, they'll probably ask this cliche question, right? So how many of you do own a Bitcoin here? Right. So have you recently done any transactions on them or no? Cool. So stolen? Yep, probably. So typically, when somebody says blockchain, we usually associate it with Bitcoin. But there are other applications or there are other areas where blockchain can be effectively used as well. So these two researchers has basically are trying to showcase one such area where we can use blockchain to detect insider threats. So without further ado, I'll just move on. So this is just another quick intro. I mean, it's the same thing as Pawan said, but we just wanted to give like a visual representation of who we are and stuff. So moving on. I tried my best to do this comedy, but I'm like, okay, cool. I'll just put a meme, right? So how many of you, I don't say how many of you. So how to say this, like, if you are attending your first blockchain presentation, welcome and thank you for attending. If you are attending your 100th blockchain presentation, what are you guys doing? I don't understand, right? So this is going to be a blockchain presentation, which basically talks about what blockchain is and where blockchain is used. And as we move on into the presentation, we'll bring in the solution that the two researchers has actually conceptualized on how to effectively use them to detect insider threats. So now I pass the dais to Sri. She'll go over what blockchain is and how it is like organized. Thanks.
Hi everyone. So how many of you know about blockchain? Is it like a new topic or? See, in this presentation, we are actually going from the basic. Any naive person also can really understand today's paper. What is a blockchain? It's nothing but a chain of blocks. So a block is nothing but it's a digital data stored in a public database. That is something called chain. That is like we are storing this data somewhere. Which is this data? It's cryptocurrency. It's the electronic cash. So blocks, they are like digital pieces of information, but they are cryptographically secured and connected. Blockchain is the actual backbone of the digital cryptocurrency. One of the main things is the Bitcoin. We have many others, but one of the main things was the Bitcoin. It's nothing but something like a distributed data structure you can think of. It's an algorithm, a distributed one. It's a decentralized one. Something like there is no central administration or authority who would actually have that central administration and see, okay, we are controlling this. So that is one of the main things. And what is more interesting here is it's containing some data. What is this data? It can be anything. It can be a transaction. It can be some purchase on Amazon. It can be some buying a property, something like a home. Any transaction can be that data. And So you have many transactions. Okay, you went into Amazon and you're actually buying some product, and when it is in transit, you actually had so much obsession and you wanted to buy one more product. And so the person is same, the product is same, then what's the difference? How are you actually differentiating the both transactions? That's where you come here, like you have a unique code. So for every transaction which is stored in the block, it's uniquely identified by a code which is called hash. So this block would be containing the data, that hash of that particular block, and also it contains the hash of the previous block, which actually connects the two blocks together. And this hash is actually a unique code. So that makes it a unique transaction. And a block can be like related to like approximate it can store 1 megabyte. So it can actually store some hundreds to thousands of transactions depending upon the type of transaction. For example, taking the type of depending upon the transaction, we can distinguish between different blocks in the blockchain. One of the transaction, we can take an example like a Bitcoin. Here, using Bitcoins, Alice is trying to transfer $100 to Bob. So, and basically for like, in general, we use this hash. Hash is nothing but like a fingerprint. Fingerprints are unique, right? In the same way, this hash is also very unique. And generally, we use SHA-256 algorithm to encrypt it, but we can use many other algorithms to encrypt, but that is one of them. So how are we linking these blocks? So each data is having one hash, the unique code, and that is actually stored in the other block. In this way, the blocks are actually interlinked to each other. Then how about the first block? First block is nothing but it's a Genesis block. It is called a Genesis block. It's the first block of the blockchain. And it can be considered as the block 0, and it doesn't contain any previous hash. It would be just having zeros as the initial code. Okay, what makes the blockchain unique, or how is the blockchain built? Some of the properties I can tell you of the blockchain are, it's actually very distributed, it is secure, it's transparent, it's flexible. How could you say that blockchain is actually secure? Anyone? How is blockchain secure? It is actually secured based upon the tampering. If anyone can tamper it easily, it's very much vulnerable. But here it is like very difficult to tamper the blockchain. That makes it more secure. If at all you see there is like a hacker, he wants to modify some of the data of a particular block. For example, here if you take a second block, he wants to modify the data of that particular block. So whenever a data will be changed in the block, immediately the hash code of that block would be modified. And what would that result in? It would actually break that link. So whole chain would be lost. So in order to tamper a particular block, the hacker should be able to modify all the blocks in that particular blockchain, and that too within seconds, without anybody's notice. So this whole chain would be lost. But nowadays computers, they can calculate millions of hashes within seconds. So the hacker could immediately calculate the hash, and he can again build the whole blockchain within seconds. So how do you go with this? What should be doing in order to make it secure? Then comes the concept of proof of work. So in order to change this particular block, a hacker has to be changing everything, right? So what we will do in order to address this issue is called something called as proof of work. What is this proof of work is, we are trying to add some amount of computational time in order to calculate the hash. This would actually slow down the process of calculating the hash. In this way, we can actually prevent tampering. So how this proof of work works? Let us see how that works. What makes it, or what slows down the creation of the blocks, is called proof of work. So we have the whole blockchain network is present. Something we call as a miner. Miner is nothing but a special set of computers who would be computing this hash or the network. They need to actually solve a cryptographically mathematical problem in order to get that block added into that blockchain. So that process is something called proof of work. So in order to calculate that and get that verified, that takes some amount of time, which validates the block. So which helps in adding, which gives the security, and then only we can actually add that block to the blockchain. In case of Bitcoin, it takes 10 minutes for each new block to generate, and in order to add it into the blockchain. Solving this mathematical puzzle is something called mining. If you heard about Bitcoin mining, did you guys hear about Bitcoin mining? This process is something called Bitcoin mining. It's hard for miners to solve, but it's easy to verify. So any block which has to be added to the blockchain has to be verified by the network. Then only it can be added into the blockchain. Once verified, it can be added to the blockchain. So in this way, we are actually adding some computational power. We are actually increasing the computational power, which increases the security for the blockchain. In order to increase the security, there is something called hash cache. It's nothing but, in order for the block to be accepted, we have something called header hash, and that should be less than the target hash. What's the target hash? So we wanted to add some new block, right? Candidate block that is having some target hash. So in order to add that target hash or the target block, we'll see that the header hash would be less than the target hash, and this is used in Bitcoin mining. This would kind of add a more level of security. And this is confirming that some work is done before adding a block. In this way, we can say that tampering is a bit difficult, and in this way we are actually securing the blockchains. So you can get it out. Who would be verifying and how would you verify? There is something called consensus protocol. Consensus protocol, it makes sure that more than 50% of the nodes or the blocks in the blockchain would actually verify the data, which the new block, and then only that can be added into the blockchain. Okay, coming to ledger. Do you know anything about a ledger? What do you know about a ledger? You could, you hear about ledger, right? Like if you are trying to purchase a home or buy a property, you try to see what is the history of that house, or I know many are trying to buy a home here, so what are the conditions you would be taking into consideration, or you just try to see what were the purchases before, what's the history of that house before. So each and every transaction is actually recorded. That is something called a ledger. So what is meant by a distributed ledger is the same, the record of transactions are actually distributed over to the millions of the for all the nodes in the network. It would be distributed, and every blockchain in every network would be having the same copy. That's something called distributed ledger. Let us see how that works. So initially user is initiating some transaction using a public key, and that transaction would be broadcasted to all that nodes in that network. So what's the next step is that every node in that network should be validating that whether that is a valid transaction or not. Once the validation is done, then they are again broadcasted that the validation is completed, and if at all, if it's a tampered block, will not be accepted into the network, but if it's a valid one, it can be accepted. There comes the consensus protocol, which I told, like if some more than 50% of the nodes in the network accept that it's a valid one, we can accept that block into the network. In this way, a blockchain is formed. This is just a brief description of a blockchain before we go into the main one. And we can say some of these are the main advantages, are some of the main key points for how the blockchain emerged. This is decentralized, it's tamper resistant, and it's cryptographically secured.
Thank you, Sri.
Yeah, so I would be giving to my friend. He would carry on from here.
So all of you made it to 50% of the presentation. Congrats. So thank you very much for giving the introduction on blockchains. So before we go into the actual research paper, right? So how many of you guys are aware that blockchain is 28 years old? The technology or the concept of blockchain is? Yes? Yep. Nice. So a little bit brief history, right? So it was in the early 90s, if I'm not wrong. In the early 90s, there were certain ledger systems that they were trying to incorporate, and they thought about this concept where how do I make sure whatever I enter in the ledger can be verified or not. So during that time, they came up with this concept saying that, okay, what if I create a pointer, sort of like a linked list? It's actually a linked list, not sort of. It's actually a linked list, right? I'll just put a hook on the previous ledger node, and then I'll have another hook on my node so that the next ledger node will know what has been changed, right? So that's where they came up with this concept. But blockchain didn't it was like a failed SpaceX rocket in the 90s where it didn't kick off. But until 2009, and most of you know if there are any blockchain experts in this room, they know in 2009, do you know who effectively used blockchain to create Bitcoin? I may pronounce his name wrongly, but I'll try. It's Mr. Nakamoto, or I don't know. The person is an anonymous person, so nobody knows who they are. Somebody claims they are the Satoshi Nakamoto, but it could be a group of hackers. So not until 2009, they used blockchain to create the cryptocurrency Bitcoin. If you listen to any TED Talks, right? If you listen to any blockchain presentations, all of them have massive respect to the creation of Bitcoin. One particular reason is that somebody took a concept that is dead and buried and made it on their own and created something that has changed the entire entire reality of currencies, entire reality of how we make transactions and stuff. So this particular paper, the reason I wanted to give this brief summary is because the researchers who came up with this concept, it might or might not be a viable concept right now, but who knows, in 10 years, maybe they can be the next Nakamoto, right? Who knows? So I just wanted to give that humble summary, and then we'll move on to what their concept is. So what the researchers were trying to do here is, they wanted to solve a problem that is very common in current security, infrastructure or current security domains, insider threats. So one example of insider threat would be, say you have a DB administrator who has access to all your DB clusters, or your ops team who has access to all your keys, right? Or who has access to all your configs. So what if they are making some changes to the system because they had that privileges, but they were not supposed to do it? Or what if I'm say for example, if I'm a DB administrator, I accidentally updated something and I didn't want to get caught. I just leave it at that. Or what if I'm an insider who wants to sabotage a company, something like that, right? So how do we try to detect that? And there might be different ways. Currently, we can look at logs. We can check for log entries to check for who did what, or we can have multiple gates in place saying that, okay, if you want to access the system, you have to go through this and this and this access control and all these things. But what if we can solve this problem with the help of blockchain by basically tweaking the DB cluster that is maintained, or by basically tweaking the DBMS system that is out there, right? So in this scenario, consider this where you have a web application that has a backend database. Consider it as a relational database, right? And then you have users of the system, you have administrators of the system, and you also have database administrators of the database system. So in this, there is this trust boundary, right? The users and the devs or admins, or basically they said devs, the admins can edit, change, or create new records on the application, and the application should be the one who should be updating the DBMS system. What if there is an attacker that is sitting as a DB administrator, tries to change a value? One example that the researchers are talking about in their paper is it's a HR system, right? HR system where you have your personal information, PII, all these, like salary information and all these things. And you have a friend who is a DB administrator who you basically tell, oh, hey, I need to increase my salary. Can you go in and change my salary, just add a 0 there? But who would validate it, right? Trust me, there are no friends like that to me. Otherwise, I wouldn't be standing here, right? So how do we do that? That is their core. That is the core concept of how the researchers are approaching this, problem, right? Is an attacker. Pardon me for the animations. Yeah, it's the same thing what I talked about. So what if we make this DB cluster centralized, or what if we make the entire tuples, or the list, the collection of tuples or collection of records in the DB cluster as a centralized ledger version by basically adding blockchain technology? How we can do that is, it's an assumption, right? So in a company or in an enterprise, they will have this PKI infrastructure, and most of us in this room know what public key infrastructure is, so I don't want to go deep into that. So the assumption on this paper is that this particular enterprise or this particular entity has an existing PKI infrastructure in their organization, right? And then they have some sort of credential management, either through enterprise AD or something like that. Let's take AD as Active Directory based setup as an example of how they manage user access to these systems, right? So the user public key can be derived from the PKI infrastructure of these users, and then we can use this user's public key to verify the DB transactions, or to add a pointer. When we are talking about in blockchain terms, we add a pointer or we add a transaction to the DB record, so that anytime there is a change, the transaction detail gets updated, and we'll be able to verify the transaction using the user's public key to see if it is really that particular user who made that change, or if it is someone else's. So what the type of solution the researchers are talking about here is, let's take a database. It has, like, say, 3 columns, X, Y, and Z, right? Or A, B, and C, or Alice, Bob, somebody. What they want to do is that they want to add a couple of extra columns or a couple of extra pointers in that ledger or in the database, which can hold a block of data. That block of data is nothing but a pointer to an existing block in the blockchain, in the chain of blockchain network. And if we do that, and then we add one more identifier into the existing database, say it's basically a user identifier. It can be user's public key, it can be a sort of a user ID that is generated, it can be anything. It basically identifies who the user is, right? So every time there is an update or every time there is an insert query, what they want to do is that they want to take the list of tuples, encrypt it with the user's private key, and then mine a block using the transaction that they just generated and put it in so mine a block is basically, that's where the intro given by Sri comes in important, right? So in Bitcoin, if you were to mine a single unit of block, it takes approximately an average of 10 minutes. The reason for that is we should not, because blockchain is a centralized one. Everybody, when you create a block, everybody in the blockchain network receives that block, which means it is distributed across the blockchain network. So if you are making a change, it should not be computationally as easy as just like creating an entry. So that's where the proof of work comes in, and for Bitcoin it is like 10 minutes on average, if I'm not wrong. So what here they will do is that once an entry is getting created, or once there is a database update, what they will do is that they'll try and create a block of data using the user's private key, and they'll try to put the data by mining a block. They'll put the data in a block and they'll do block mining. Once they get the approval and transaction that the block is created, what they will do is that they get the transaction identifier and then, if verified, store it in that block hash as a block hash, right? So basically this block hash is nothing but pointer to the data existing in that particular mined block. And then, as I said, the user would be the user ID. So which step where it might be feasible in their approach is basically they'll extract, it's basically what I said. They'll extract the data that they want to add, and then they'll digitally sign using the user's private key, hashes the generated tuples which is needed for blockchain, and then broadcast that hash value to the blockchain network. And this particular thing is very important because not everybody can add a block to the blockchain network. There has to be a common consensus, right? So if you own a node in a blockchain, and if you create a block, that block will be broadcasted to everybody who's in that particular blockchain network. They'll get a copy of that hash. That's what makes blockchain secure, right? So if you want to broadcast this hash to the blockchain network, at least 50% in the blockchain network, at least 50% of users or 50% of the nodes in the blockchain network has to come to a consensus. That is what is called as consensus protocol. The reason for that is no single entity will have full access. At the same time, you don't need 100% consensus. So basically, if a majority of the node in a particular blockchain network accepts this broadcast, then that particular hash value will be added to the blockchain network by basically mining, it's called mining a block, and then it will get added there, it will get distributed across the network. And then whenever we query that particular transaction identifier and the hash value of the transaction in the internal log, we'll be able to retrieve it from the blockchain and compare it against our entry, saying that, okay, the user who made this transaction does not have access, or the user who made the transaction hasn't modified it. It is someone else who is modifying it, because the signature now will change, right? So that is their core premise. I think they gave it, yeah, it is explained here. If a block is found, and if it compares again, if a block transaction has this user ID, they'll verify the signature using the user's public key, and then they'll decrypt the data and check if the tuples are same or not. If the tuples are different, you know that there is a change, you know that someone who is unauthorized to change the data has changed it, right? So any questions on this so far, right? So this is their solution, and there are certain assumptions here, and to be honest, this is a theoretical approach, like I said earlier in my talk. So this has not been implemented yet. We don't have any validations or results to show you guys, but it is a work in progress currently. The last time I spoke to the researchers, it's a work in progress, and then they'll definitely try and improve this moving forward. But they wanted to present this to a broader audience to gauge what their responses are, to try and see what the temperature of the room is basically, right? So to see if this is something that we think is, the next thing or the next, like application or the next usage of blockchain. So, any questions?